Hello, welcome back once again. Today we got an interesting problem to solve. We have 9 to the power of x plus 3 to the power of x is equal to 20, and in this video we're going to solve for the values of x. So let's get started. From the left hand side, we know that 9 as the base, right, can be expressed in index power of 3 as 3 to the power of 2. So we're going to write the equation as 3 to the power of 2 raised to the power of x plus 3 raised to the power of x. This is equal to 20. Now let us apply this rule. We know that a to the power of b to the power of c, we can switch the powers as a to the power of c then to the power of b. So this right over here will become 3 to the power of x to the power of 2 plus 3 to the power of x. This is equal to 20. Now we're going to make the following substitution. We're going to let 3 to the power of x equals y, right? So now from here we get y squared plus y is equal to 20. We get y squared plus y minus 20 is equal to 0. Sorry for the noise. I'm so sorry for the noise. Okay, so now we're going to look for two terms that when you add them, they will give you positive y, and when you multiply them, they will give you y squared times negative 20, which is negative 20y squared. This is what I mean, negative 20y squared, when you multiply this first term and the constant here. And then we have, for the addition, we just get y. We're going to look for two terms that when you multiply them, you get negative 20y squared, and when you add them, you get just y. So I'm thinking of negative 4y and 5y, right? So now we're going to write the equation as y squared. So instead of y, we use this. So that will be plus 5y minus 4y. Then minus 20, this is equal to 0. From here, y is common, factor out y, and we have y plus 5. Here, negative 4, factor it out, and we have y plus 5. And this is equal to 0. So from here, we have y minus 4 multiplied by y plus 5. This is equal to 0. And from here, this implies that either y minus 4 is equal to 0 or y plus 5 is equal to 0. So from here, we get y is equal to 4 or y is equal to negative 5. Now let us recall that 3 to the power of x is equal to y, right? And we're solving for the value of x, so we're going to solve for both complex and real values. So for real value, y need to be greater than 0, and for complex value, y need to be less than 0. So we can see here y is greater than 0, so here we are solving for real value for x, right? And for here, y is less than 0, so we're going to solve for complex value of x. So for real value of x here, we have 3 to the power of x is equal to 4. Now take the natural log on both sides, so we get the natural log of 3 to the power of x. This is equal to the natural log of 4. And with the property of logarithm, this power will come down. So we have x times the natural log of 3. This is equal to the natural log of 4. Divide both sides by the natural log of 3, and we get our solution that x is equal to the natural log of 4 divided by the natural log of 3. So this is the only real solution to this problem. And for complex solution, we have 3 to the power of x. This is equal to negative 5. Now ln both sides, we get the ln of 3 to the power of x. This is equal to the ln of negative 1 times 5. Yes, of course we can write that. And here we have two products as the argument of the logarithm, right? So we're going to write in addition form. So this will become x times the natural log of 3. This will be equal to the natural log of negative 1 plus the natural log of 5. So from here, we have x times the natural log of 3. This is equal to the natural log of negative 1 is I pi. I've talked about this in my previous videos. Then divided by the natural log of 5. Divide by the natural log of 3. So you can see this will cancel this, and from here we have our complex solution. that x is equal to I pi plus the natural log of 5 divided by the natural log of 3. So this right over here is our complex solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.